All right, so today's lesson is about Python functions. We have already looked at functions, but not specifically with Python. We looked at functions in the context of our pseudocode and our flowcharts. So in the pseudocode, we actually had a lecture, and you can go back and look at that, which was pseudocode and functions. And a lot of the stuff that's in this lesson, and even some of the slides, were in that lesson, so you can look at that. And also during that lesson, I did show you, I think, some Python from last time. So I'm hoping that most of the stuff that you'll see in this lesson is not too new, but even if it is, that's okay. We can learn it as we go, wherever you are. So in functions, we say, what is a function? What do we use a function for? We're going to have a little bit of code, which we might use more than once. We're going to spend a bit of time sort of perfecting that code, and we're going to define that code in Python. We have a special command to do that, and then we can reuse that code whenever we want. We can call it and use it whenever we want. And as this says, there's certain components or parts to a function. And so you're going to have, and you can see that in this function here, in this blue little rectangle represents a function. So the function has a function name. It could have a return value. It doesn't have to have a return value, but often does. And in this case, Z or Z, however you say that, that is a value, that's a variable actually, which has been taken the value of the return value of this function. So you wouldn't actually have something called function. You'd have your own name there. You make up a name for the function and you put it there. Then the X and the Y here, they actually represent two parameters or arguments or inputs, local variables, we could call them. These things came up a lot in the tests that we had, by the way. So they represent the inputs for the function. The function is going to take inputs, again, optional, doesn't have to take inputs. And welcome Hind and Roa. So I do have some students here with me. That's nice. And it can have an output, in which case it would be the return value. So some special things in Python. This slide is, so the previous slide, we're just talking about functions, and we talked about them before when we were doing pseudocode. But this slide only refers to Python. So with Python, we actually use this special keyword, def. Def, I think it probably stands for define. So in other words, so we define the function. We say def, then we give the name that we're going to have for that function. We specify in brackets, as it says there, what parameters, which inputs are going to come with it. And then after that, we put a colon. Then everything that's going to be the instructions that will be inside the function, they'll be indented after the colon. And then you could have a return statement, as it says. The return statement will be what, and you can only return one value, unfortunately. So you can't return X and Y and X and Y and Z. You can only return one of them. Whereas you parameters, you can have multiple parameters. You can have X, Y, Z. You don't have to have 2 or 1 or 5. The number of parameters is determined when you define the function. And so it's up to you how many parameters you make it. But, and likewise, it's up to you if you even have a return value. So you could have a function that didn't have a return value, or you could have one that did. And we'll see both of those kind of functions. We actually have some functions that are built into Python that we use, and we'll talk about in this lesson. So we have this word that we use, which is call. We call a function. So here it's in the past tense there. A function is called when the name of that function is used in some other part of the program. And when the name of that function is used, any parameters that have been defined with the function will be put inside the brackets part of the function, and they will be inputs for it. Also, any return value will be set to, will be used however you're going to use it. And so as it says, the function is only used when it's called. So we have this steps in the use of a function. First, we have to define the function. Then we have to call the function. when we call the function, then it's executed. Only when we call the function is it executed. This slide, I hope you recognize. I hope this slide is familiar to you. We've seen this slide before when we were talking about pseudocode and functions. So on the right, we have a black box. And I think the black box is not a coincidence. The black box is actually a word that or a term that we use to represent something where we can see the outside of something, but we know what goes into it and we know what comes out of it, but we don't know exactly what's going on inside there. And you could say that here, right? Here's a black box. We know that something's going into it, assignment, quiz, and test. We know that overall value is coming out, but we don't know how that's going to happen. And that's basically how it would look in a flow chart. So we can say that's a black box.
The process for the flow chart.
Sorry?
The processor for the flow chart.
I'm not sure what you're asking me, Roa, but this is a flow chart which shows us a function, and the function is in black. And another thing about that function is it has parallel lines on the other sides. That's how we know it's a function, not just a command. All right, so about the function. Now on the left, what we've done on the left there is we opened up the black box. So here we have the black box where we can see only what's going in and what's coming out. We don't know how that's what's happening inside. So over here, we're showing what happens inside. So here we have what's coming in, X, Y, and Z. Here we have what's coming out, A. Here we called it A. Here we called it overall. Here we called it X, Y, Z. Here we called it assignment, quiz, and test. So you can do that with functions. Here they are global variables. Here they are local variables. This came up in the test, by the way. I saw everybody was having that question. Some people were struggling with it a little bit. Now, as to answer questions that you would have seen in test 2, these variables here at this point inside the function, they are local. They can only be used inside the function. Now, I described that in a previous lesson when we were talking about functions in pseudocode. I described it using the example of the stack. Right? The stack, the idea of the stack is we put things on top of the stack and then we remove them from the top. The idea there is last in, first out. But that's how a stack works. So when we create the function, these variables are there and they end up in the memory, but they are only living in the memory during the time that function is executed. So before the function is executed, those variables X, Y, and Z do not exist. Afterwards, they do not exist. Only during the time that the function is being executed do those variables exist in the memory. Whereas these other variables here, assignment, grade, test, they will be in the memory for as long as that program is in the memory. So what you're looking at now is not Python. What you're looking at now is pseudocode. And so this, I hope that you would remember this and what are the difference between Python and pseudocode. Python, we use the word def. It's not a word, but we use a keyword. Yeah, here we just use function. Then we got the name of our function. The other thing that's different in pseudocode is each of the variables, we have to specify what type they are. Don't have to do that in Python. Python will sorry? X, Y, and Z. Yeah, all you'd have to do is put X, Y, Z. The other thing about pseudocode is you have to put this curly braces there. You don't use any curly braces in Python. All right. So what we do in Python is we just put a colon there. And so again, in Python, you wouldn't need this int. You wouldn't need this float. The return thing would be the same. Also here, you wouldn't need that function there. You wouldn't need the curly brace. You'd use a colon, no int, etc. Otherwise, pretty much the same. All right. So this is actually how that same bit of code would look in Python. So we see what's happening. The two-step process, if you want to call it a two-step process, the blue thing here is the function. The function here has got its local variables X, Y, and Z, which only exist while the function is being called. Local variables X, Y, and Z and A. So what happening is these come in as inputs, and then S is calculated using those inputs. And then A is calculated using S, and then we return A. So A becomes the output. The inputs were X, Y, and Z. So we define the function here. The program actually starts here with assignment equals. That's the first bit of program that's run. And it's only when we get to this point here that we actually go ahead and run that program. Now, you might remember this from when we were doing the functions before, because we have done this before. And so you may have seen me do this in idle before, but this is average function. And how a function works is you always have the two-step process. You've got the definition, all right? Now notice everything in that function is indented. Even the return statement is indented. So just as it showed in the slides, we define the function with its name, the input variables, a colon, then the instructions, lastly, the return statement. Now here's where the actual program starts, here with assignment, and the function is actually called here, where it says average takes the value of the return value of that function. Now, I'm just going to look at that and make sure that all of our code is okay, because it is sometimes comes across not exactly okay. I think that looks okay, so we could do that. I think a good thing to do here is, remember sometimes we put line numbers in our code just so we can see what's happening. So I'm just going to put some line numbers in here, because maybe if I put some line numbers in, we could, we don't need line 4 there. What I'll do is I'll put a print statement in here. So we're going to print, and here we're going to print line 4, and we're going to print a S. What else we got there? X, Y, and Z. So we're just going to print all those values. Of course, nothing will happen there until I put those values in. I'm going to do a bit of copying and pasting here, stuff that I hope you will recognize. So we've done something like this before, right? So we're going to put our values in there. So I'm going to copy all of this.
Good morning.
Hello.
See, I'm not coming in the morning, but I come now.
Oh, that's fine.
After eating food.
I had to come this morning.
Good morning. Mister, after you finish class, come. I have to talk.
Yeah.
Come eat with us and drink coffee.
Yes, that smells good.
Sir, now I like your class. You know why?
Why?
You got for me same my cousin Mark, 22.
I had to put the marks up
Thank
because after talking to the other teachers, they said, "Oh, that's marking too hard." All right, so we had to do that. My mistake. So I did change the marks.
Sir, not mistake. That's our mistake because we not study well.
All right, so that will print it out line 4. So this would be, let's get some other lines on there. So that's line 4, line 5. This would be line 6, right? Line 6. So we can just see what happens at what place. So this is going to be line 7, line 8. And that would be line 9. And this will be line 10. So the reason is because we'll be able to see how this actually runs. Well, let's run the module and see. So this is average function. So it asks you for an assignment grade. Let's just give any grade, just some grades that are reasonable grades, I suppose. And so what it does, what I wanted you to see is the line numbers, right? So line 6, then line 7, then line 8, then it goes to line 4. Anybody can tell me why it goes from line 8 to line 4. So if we look back at the code, I missed my hash here. But we see that it actually starts, if you look at the printout, it actually starts at line 6. And that's because this is where the main program starts. There's nothing before this. So you might say, well, what's that stuff above? This is just defining the function. The stuff above is just defining the function. Here is where the program starts. And so it goes 6, 7, 8. when it gets to 9, we see that that's when it prints line 4, because that's when it's running the function. Where's that? Sorry, I'll come back. After 8, it goes to line 4, because that's when we do the call. The function call is at that point. Anyways, I hope I made that clear. How the function works, we define it, and then the way this program works is it starts here. It doesn't actually go and do this stuff up here until it's called below. So the next slide here tells us about some special built-in functions in Python. You will have used these. So what's happening here, right? We have some casting functions. Now, what happens with these is you put in one parameter. With the int casting, you put in any number, or it could be a float number, or it could be a string. And what will happen is it will return an integer value. Likewise, with the str function, you put in a number and it will return a string. With the float function, you put in a number or a string and it will return a float value. The len return, you put in a string. So here x is a string, and you put in, that's the input. And what len returns is an integer, which is how long is that string, how many characters in the string. Input, you've seen this before, the x there is also a string. What happens with input is it will put that string as on the screen, and then whatever the user types after that will be returned into whatever variable you set that to. Print, so here's one that doesn't actually return a value, right? So you can have a function that doesn't return a value. Here you input a string and it just puts it up on the screen for you. That's all print does, is it takes the string that you put as a parameter and put it up on the string, on the screen. So we got some other functions. All right, so absolute, the input is going to be some number, an integer, which could be a positive or negative integer, and absolute will return the absolute value of that number. So that's only really important for negative numbers, I guess you could say. So if you're doing quadratic equations or something like that, where you had to know the absolute value of a number from a square root or something like that, because you know square roots, you could have 2 negatives multiplied together makes a positive. Anyway, so you may have to use absolute values at some time for some of your mathematics. Power, you input 2 variables, 2 numbers. The first number is going to be the number on which you're going to raise to the power. The second number is going to be the power that you raise it to. So like you could raise, so 5 squared, you'd put 5 comma 2, and then that should return the value. It will return a value. It should return a value of 25, right? 5 times 5 is 25. So 5 squared would be 25. ASCII, so what this one does is you put in a character, so it's the input is actually a character, and it will return for you a number between 0 and 255, and that number relates to an ASCII table. If you're interested in that, just Google it and you'll see the ASCII table. It has the number 0 to 255. Every character on our keyboard that we can input into the keyboard has a special number that we can refer to it by. CHR is character. Basically, what you do here is it's the opposite of the ASCII function. You input an ASCII number. So the X would be an ASCII number and it will return a character for you. Bin, here you put in a integer number and it returns a binary number for you. So you can get a binary number from an integer. So remember those calculations we did? Don't need to, right? We got a built-in function to do that. Likewise with the hex, you put in a integer number and it will return for you. So it will return for you a hex number. Now, the point here, I hope you'll get this, is people go and write really nice little functions that are so good that they want to share it with the rest of the world, or the rest of the world wants to share it. And so those functions will be saved in libraries somewhere. Now, some of those libraries come with your distribution of Python. So when you downloaded your idle, you're going to have some libraries that come with it. But those libraries will not be loaded up into memory just automatically. If you want to use that library, you have to load it up into your memory first. And how we do that is we have this command called import. You have to import that library into the memory so that you can use it with your Python while you're running that Python in that session. So one of the libraries that you can use is a library called math. And so if you want to use any of these functions that go with it, for example, square root, pi, you can use them, but you just have to import it. And now here's the point that I want to make about importing. I mentioned that some of these libraries are will come with your distribution of Python. So when you downloaded the idle, you would get Python, but you'd also get these libraries would come with it. Now there are some libraries, and some of these libraries, some people right now, as we're talking, are somewhere coding and making some new functions for libraries, and they will store them on a server somewhere. And then when they think they're really good enough, they'll send things out to other developers, because Python is an open source language. And so there's lots of programmers around the world that are adding to it all the time. So somebody might come up with some really neat library. Maybe it's some library to help you to do something with Twitter, you know, or to do something with your crypto security. You know, there's lots of developers working with Python all the time, and they're developing new libraries. So you might get this thing and you're working on something, you're developing something online, and you find out that somebody in, I don't know, in India or in Russia or Ukraine or something like that has developed this neat library that does this cool stuff for you. You say, okay, I want to use that library. Now, of course, you'd have to be careful using a library that's on another server, because maybe it's full of viruses or something. But you know, you would check and you'd find out that, yeah, this one is okay. And then what you'd be able to do is you'd be able to use the import command, and then you would use a URL which would say where is that library. And so that you could, as long as you were online, you could open up that library from the the server and use that. All right. So math library, you don't have to do that. It's distributed with Python, and you can just use it. And okay, so for example, at the start of your program, you import the math library. Then you want to use some math library functions like math square root. And so here we are using math square root and math pi. And so we can do this because we have already imported math. If we hadn't done the import, we wouldn't be able to do this calculation. I think we've probably done that calculation at some point. Here's some other functions that come with Python. Now these functions, they're special because they relate to strings. And what's special about a string? A string is an object in Python. Python is an object-oriented language. Object-oriented languages, the objects can have methods and classes associated with them. When you have a method or a class that's associated with a object, you specify that with the dot coming after it, right? So dot is upper. It says that, now the thing, there would have to be something in front of the dot. What would be in front of the dot would be the string that you're going to do this on. So you create a string that becomes an object, then you can use these functions that work only with those kind of objects, which are strings. And so for any string, you can change it to uppercase, you can change it to lowercase, you can change it to capitalized case. We've done that. So in front of the dot would be the string variable name. Yes, Hind?
We have to write this or direct upper and lower? We have to write S lower or S upper before the.
All right, that very good question Hind's asking. Basically, I think I'll answer the way you asked that question by what's the difference between upper and is upper? There is a difference. So the upper function, what that will do is it will take any string that it is attached to. So you don't put a parameter in it. Come on. You don't put a parameter here, but this name of the string will be before the dot. But that string, it will change that string to be all uppercase. Now the is upper is a totally different function. What the is upper does is it's Boolean, and it will be either true or false. It will return an either a true or a false. It'll be true if the the string which it's attached to is uppercase, and it'll be false if it's not. And likewise with the lower, is lower, if it's lowercase and you do is lower, it'll be true if it's lowercase, and it'll be false if it's not. Same with numeric, basically saying, is it a number? Is alpha? Is it a letter of the alphabet? Is alpha num? Is it a number or a letter of the alphabet? So we use these things. Where we would use these things when the user inputs like a password or some special code, and it has to be a certain way, then we can use these to find out. Yeah, we're running out of time. Oh, imagine that. All right, so what about print? Oh yes, print is a function. It's a function, so it has inputs, which are the arguments, which is the stuff inside the brackets in the print. Print has some special arguments that can work with it, like /n. /n is going to give a new line, which means that whatever happens after the /n is going to be on a new line on the screen. And we have this other one called end, and I think you might have seen this in some program that I've done with you. And what end will do is, instead of going to a new line, it'll allow you to print the next line that comes after the end on the same line that it is. So this is what we mean by that. So notice this print statement. After the thing that we printed, we do a comma and then end equals space inside quotes. So what that means is, instead of going to a new line, just put a space between this and whatever comes after it. And so what's going to come after it is another print statement. So these two prints won't be on two different lines. They'll be on the same line. See, hello world, hello and world. They put them on the same line instead of putting them on two different lines. So we kind of are running out of time, but maybe we have enough time to trace this. Let's see. Come on, there we go. We can put that into Python. So I'll get a new page for it. This one is, I don't know, it's a math trace or something like that. So if this is line 1, you can tell the trace by, all we have to do is put a print in it, right? Line 2, line 3. I could put a print here. That would be my trace. Print A. Do it easier way this time, just like that. Print A. Is there anything else we need to print? A is enough. And, oh, well, say what line we're on. What line are we on here? This is line 4. And, okay, so this is line, what's this? This is line 5. So this is line 6. Oh, see, that doesn't work because that got the wrong kind of quote there. But this is line 6. And this is line 7. There's no print on line 7, but there is a print here on line 8. So what we should see is we're going to see the print is going to be, we're going to see line 6, then we're going to see line 4, then we're going to see line 8. And I wonder if you can tell me why we're going to see 6, then 4, then 8. Can you imagine why that is? And we'll look at it and we'll see. Okay, so let's run this and see. Run the module. Why is it going to be 6, 4, and 8? Well, first off, am I right? Is it going to be 6, 4, and 8? So this is a math trace. Called it invalid syntax. Okay, because I got something after the A. And I didn't see that. Should have been wearing my glasses. But put them on, right? So it asks for a radius for the computer. Sorry, for the circle. So I'll put a radius of 4. And then we get the numbers. Now, 6, 4, 8, as I predicted. So why was I able to predict that it's going to go line 6, 4, 8? The program actually looks like it starts up here. Well, it does start with line 1, but we don't do anything at line 1. But this is the main. This is the main, and so we can say that this is where the program starts. Actually, this import is the first thing that happens. But then we see 6, 4, 8. 6, 4, 8. Because why? Because when we get to line 7, that actually goes and executes this function. And that's why we print line 4. So I hope that's clear. And I hope we follow that trace. Again, the idea of following that trace is just so that we can see the way that the function goes, which is that we go to, we declare the function or define it. After we've defined the function, then we have to call it. This is calling the function. Call the function there. This is defining the function. We define it, and this one has only one input. The input is R. We call that a parameter. That's going to be a local variable. See, it doesn't show up anywhere else down here. Here it's called radius. This is the global variable radius. Global variable area. Here we have a local variable A. We return the value A, and returning the value A is the return value of the function. So when this function is called, it takes the variable A as its output, and that becomes area, and then we print the area. So I hope that makes sense. That's our function. And how we doing for this? Just about done, I think. So you are supposed to write a function that takes the side of a square, displays it, and actually they've done that here. This is what you're supposed to write. Here's the function. It takes the side of a square as an input, and it squares it using the power function from math. So this is from the math library. That's why you had to do the import math. Okay. I think we got a better one than this, where we actually do it like 5 times. So let's have a look. Yeah, that's the last slide, right? So there it is. We can write that. Hopefully this kind of makes sense. Let's just copy it and put it into Python. So this is, we'll call it 5 squares. Square 5. Shouldn't start with a number. So why I called it 5 squares or square 5 is because we call this function 5 times, right? We call this function 5 times. What we should print here. So let's put our numbers here. So this is line 1, line 2, 3. Okay, so this is actually a function that's calling a function, isn't it? It's calling the math function and performing that. Line 4, line 5, 6. Now I can just put the line 7 right here. Now, so that's line 7, that's 8. And so that's 9. This one is 10. So I think what we ought to do here with this one is we should also print the count. Just for fun. I think we can do it like this. Might not be able to, we might have to put it, might have to convert those to strings. Maybe just to be safe, we should just do that anyways. Okay. And there. So why I want to print the count is that you're going to see that this is going to go 5 times through here. But here, yeah, I could print the count in there. Don't need to. We should have a print statement in here though, before the return. So let's print A. Without being capital. maybe we should print the line number there. So this is line 4. It's actually gonna be line 4. Line 4. So we'll see line 4 is gonna happen like 5 times. And yeah, that could be fun to watch, right? So there's line 7. So we should see this go 7, then 4, then 10. 7, 4, 10, 5 times. That's going to be kind of fun. Let's watch it. So square